Hi everyone, Nate Solves Problems back here with a in-depth look at approximating e to the x with its Taylor series expansion. So if you're familiar with the series of e to the x, the first term's 1, and then we have x. So we can see that this is good for only a little bit of e to the x. It only can approximate a small portion of it here. So what happens when we add the second term? We know that that term is x squared divided by 2 factorial. Starting to get better, as we can see. We're starting to get more of that curvature, except when x gets large, it starts to deviate a lot. So let's try another term. So series expansions help you to really get a good idea of how that function acts and how you can approximate that function. As you can see with small x, you only need a few terms to get a good approximation of e to the x. But as your x gets larger, you're going to need more and more terms. This is true with the other series expansions as well. If we were to look at sine or cosine or ln x or tangent x, we would need more and more terms as x gets larger. So here is just a good visualization of what happens when we start to add more and more terms to that approximation. We get closer and closer to valuing the function as x gets larger and larger. But we can expect we know why we need more terms as e to x gets large. It grows very rapidly. It is a power function. And we're trying to compare it with x cubed. We're not going to be able to keep up with it. So we're going to need a lot of terms to have a really good approximation of it. If we move up higher, we can see how this starts to deviate more and more and more. So let's add the fourth term, or what would be the fifth term, or the x to the fourth term. See how closer we get? How much closer we get? And the same thing happens as we add more and more terms. So we can really see how that series approximation is good. The series expansion is good at approximating that particular function. I hope this to serve as a good extension to deriving the series expansion of e to the x or the derivative of e to the x, in hopes to kind of use this to compare with the other series expansion videos and the graphing portion of them, and really get a visual idea of what's happening with these functions. I'm using Desmos to graph this, and it is great. It's a free resource. You could just go on Google, look up desmos.com/calculator, and you can find this exact software for whatever you want to graph. So thank you again for watching. See you in the next video.